I guess you've heard the remark that an expert is anybody who's 50 miles from home, and I'm certainly 50 miles from Hong Kong. You've also heard the remark that forecasting is difficult, especially of the future, and I'm going to be trying to forecast the future. So can we look at the next slide, please? So I think the important thing is that, as you can read, the present day graduates of higher education are students who join a different world. They're going to join a world where, as you can read, is almost effortlessly accessible. The cell phone and the internet have brought a tremendous amount of data and many problem-solving techniques to everyone, including those working in engineering and other science-based fields. And the information is conveniently accessible when the user wants it. And this is entirely different than when many of us went to school, where you had to find the right book and find the right page and understand the author's conventions. Now we just click on a couple of things and there it is. I think a second reason why the world was different is that people are going to be doing jobs that don't exist now. And I don't mean that there won't be any jobs for example, electrical engineers. I was trained as an electrical engineer, but what electrical engineers are going to be doing in the future is really much different than what electrical engineers did in the past. When I was in school, we were taught how to, for example, design a transformer, and you looked up in the tables the quality of the metal that was in the transformer, and you looked up the quality of the kinds of copper wires you needed, and you found some standard configuration, and you did calculations to see what size metal and copper you should use. All that's now done by a computer, and it's going to be that way for now forever. I think another reason, down to the third bullet, another reason that the world will be different is that it's getting smaller in terms of how easy it is to communicate with other people, and the effects of what happened in distant places are going to be important to us. A respected book claims that the world will be hot, flat, and crowded. We can talk about global warming later, but certainly the barriers for information transfer have diminished. And the events, as I said, the events happening far away will affect our lives a lot. And it's not going to slow down. The pace of change is going to accelerate. Why will it accelerate? Because the first bullet, because so many people are going to know so much information that they are all going to be making changes. Thank you. So I was talking about the pace of change will accelerate. I guess you know that at least in the US, it took about 60 years for the ordinary telephone to become widely accessible. It took about 13 years for the cell phone to become widely used, and it took 8 years for the smartphone to be generally accepted. Things are happening much faster. In my course in entrepreneurship, I start by showing some slides about how long it takes to get a piece of medical equipment approved, and then I talk about how long it takes a piece of software to become accessible, widely accessible, and the difference is about a factor of 10. And so the implication is, as we've often said, what our students are going to have to learn is how to learn themselves. Can we have the next slide, please? And the first bullet, I think, is self-evident, that no one is going to be able to handle all the useful and relevant information that exists. We're going to have to find ways to handle it. And one way certainly is that we are going to have to be able to learn from others. That before, in the past, we could get a book out and sort of get the ideas from the book. Trouble is, when the pace of change is so fast, the books tend to be out of date, and we really have to get the information from other people. Artificial intelligence will become common, and I'm not worried about artificial intelligence, because I think it's going to suggest new ideas and new possibilities. And I think it will augment creative thinking and replace routine thinking, which of course is a worry for people who basically have routine jobs and all that. I've alluded to this other point, that decisions in one area, such as engineering, will have increasing implications in other areas. So you put down a irrigation system, it affects the environment in many ways, and the increased agricultural output is going to be used in different ways. And I think the world is getting crowded. What I mean by getting crowded is that the number of people or things that we have to be close to is getting much larger. And again, going back to an irrigation system, in the past, if an engineer made a mistake in his design, then the particular people who owned the field were damaged and hurt, but that's about as far as it went. Not true anymore. Now, everybody in the village is going to know, everybody in the community is going to know, everybody in the world is going to know. It's just less likely that mistakes can be hidden. Next slide, please. So what I want to talk about is, and you can read it, so I don't think there's any point for my doing it. And so why don't we go to the next slide? So what about effective teaching? And I think effective teaching will change, because students will realize that they can look up for themselves a whole lot of information and a whole lot of techniques for doing design. They simply won't want to waste their time trying to follow things that we tell them, because they know that there's no point in them storing in their brain when the internet has already stored it for them and made it easily available when they need it. And just to reiterate the point, traditional teaching often focused on transmitting information. A transistor works like this. Here's the step-by-step process for designing an amplifier. All that is in the internet now. And the techniques for design, where we faculty members have spent time explaining things to students, now it's all on the computer. So again, I'm repeating, effective teaching will be training students to learn how to learn on their own. And obviously, I think you see the connection to experiential learning. With real world problems, students will have to learn fast, and they realize that they're going to have to learn fast. Next slide, please. So in creating effective teaching, it seems to me that we have to we have to worry about two things. The first one is that I don't think we can really teach students anything. All we can do is to encourage them to want to learn. And we can also we can also structure the material so the students can learn on their own quickly. And I think the second thing that we as academics should be thinking about in our teaching is what happens in the real world. How is professional work done? What will our graduates actually do? And I realize that it's unfair to base remarks on a small sample. A small sample on basic remarks are the students that I look at every day. And it seems to me, on the one hand, they really are more engaged when they feel that they're accomplishing something in the classroom. But on the other side of the coin, they're less engaged by material they perceive as routine and something that they could look up and all that. And obviously, I think service learning is related to both of the points in the first couple of bullets, that service-based learning does engage students. It does show them that what they're doing in the classroom is important and worthwhile. And second, it shows how professional work is really done. And I think we've all had this experience of talking to a student who has come back from a service project, amazed at what really happens in the real world, and how projects are done, and how important it is to be cognizant, to understand the motivations and concerns by the other people who are involved, the local people. And what I was trying to get to and the last bullet is that service-based learning implements the project, and somewhere along the line, the student all of a sudden, I think, realizes that if I make a mistake in this project, I'm going to hurt a family, I'm going to hurt a community. If I make an electrical system that's going to fail after 2 weeks, then I have done damage to a family, to a group. I'm sorry to bore you with my own stories. I teach a course called The Engineer's Burden. And the engineer's burden is, among other things, to make it work, and to make it work reliably and economically for 20 or 30 years. And that's a tremendous responsibility. Uh, and I think you understand the point I'm trying to make, that service-based learning really shows what an engineer or any sort of person doing technical work uh, can accomplish and should accomplish. Next slide, please. So let's just talk a little bit about professional work and then also collaboration. And let me talk about professional work first. And this is probably what I'm going to say has probably been true for many years, but I think it's even more true these days. It seems to me that professional work, places I've observed, uh, consists of a few very capable specialists who know their technology very, very well, and more important, can innovate and create new things uh, and form the basis of a technology that a company can use. The example is most current in the software business, the people who actually do the coding. And I'm just making up a number, 5 to 10% of the people in most companies are these few very capable specialists. So what about the other 90%? The other 90% might be called applications engineers, and they're the interface between the very capable specialists and the user. And let me just talk about the second bullet for a second, and then we'll get down to, I think, the important point, which is really the third bullet. Second bullet says that 90% of the output comes from 10% of the workers. And I think that's a misunderstanding. That's the point. The observation is that these very few capable specialists turn out impressive and innovative ideas, and it looks like that's the real importance of the company. But it isn't really the real importance of the company. The real importance of the company and the organization is what it does to help other people, other engineers, other users, and that's what these other application engineers do. And the other observation here on the second bullet is winner take all. And what I'm trying to get to is that, in fact, if you have 3 or 4 different engineers, all of whom with good ideas, and one of them with an exceptionally good idea, it's almost always the exceptional idea that takes over, that the 3 or 4 other people with good, sensible ideas simply don't have any real output, real effect, real technology to show that one or two exceptional people really make the difference. And of course, the other observation of this is in most industries, automobile industry comes to mind. We don't have 20 different companies making, for example, a low price car or medium price car, or even an exceptionally well designed car. We have 1 or 2, maybe 3 companies, the winners, and they do it all. All right, let's get down to what I think is the important point. the important point exists. The important point is that a need really does exist for the people who are not doing the innovative coding, but the people who are, as I said before, the interface between the exceptional people and the users. And that is what I think is what most of our graduates are going to be doing. And I think, although it's easy for academics to disparage these kinds of people, they're in fact the ones that make the technology effective. So what's the point I'm trying to make? The point I'm trying to make is that in order for a technically oriented person to be useful, he or she has got to be good at explaining technical ideas and recommending technology to others. They have to be good at collaborating. And the final bullet is just an observation, but I think it is relevant that when you look at the background of the very capable people, the 10% that I was talking about in the first bullet, I'm struck by how few of those have advanced degrees. That many of them actually were college dropouts. They went to college for a few years, university for a few years, and my impression is we're just bored, that they, being on the frontier of knowledge, is not where the classes are. They wanted to do their own work on their unhindered by academic systems and restrictions. Next slide, please. So again, we're trying to get it back to what is going to be important in the graduate's professional life. And obviously, they have to be able to learn new technologies and understand them so that they can use them and give advice to people who are using them. But I think what they really have to be good at is thinking broadly and okay, something I wanted to say on a previous slide, but forgot to do it, is that many academic institutions tend to focus on that top 10%. And I think you know what I'm about to say. The top 10% of the people probably don't really need faculty, and it's the other 90% that are basically not rewarded and recognized, and often have an education that doesn't quite help them. So going back to what do I think is going to be important in a graduate engineer or scientist in her lifetime is, I'm repeating, thinking broadly and collaborating. And thinking broadly means, and you can read it, it means basically taking ideas and using them in non-obvious places. And also thinking broadly recognizes possible unintended consequences. And I think we're all familiar with some of the unintended consequences of technology. in the U.S. there is concern with young children watching too much on the internet, and their learning is being effective. There are many stories coming out about how new highways came in, and new highways were built by engineers with the hope of solving traffic problems, but in fact did great damage to communities. And I think we all realize the unintended consequences of using fossil fuel to the environment. So I think it's important for modern graduates of modern programs to be willing to consider deeply the context of an engineering decision. What's going to happen when we build high-rise houses with few amenities and so forth. Again, I hope students come back from a service learning experience with a realization that everything is connected to everything else. That if you bring in, I'm thinking of the Green Revolution, if you bring in high yielding seeds, then you have to, on the one hand, bring in fertilizer, and on the other hand, you have to find a market for the product, and you have to worry about disease when every farm is using the same kinds of seeds. Everything is connected to everything else. Next slide, please. And again, what I think the engineer or the scientist in general in the future is going to have to do is be able to work well with other people. There's just too many possibilities for one person to know everything. And service-based learning clearly does this. The projects that most of the projects I know about put students in unfamiliar context. And if they're going to do any good, most of them realize that they have to understand what's going on in these other villages where people have other needs than they're used to. But I think collaboration has other examples, most of which are self-evident, that if you're doing a design, if you're a designer, if you're have any intelligence at all, you realize that you have to show it to somebody else, because a designer gets enamored by what she's doing and doesn't recognize problems, and so a collaborator will gently point out that this might happen and that might happen and so forth. And I think there are other points here. A team, for most people, motivates and engages when when students or an engineer are discouraged and feel badly. A team is going to be support and help them. And I think the other thing that service-based learning does is develop a respect for other people, that these local people that we think we're helping, they've got lots of good ideas too, and they know what's going on. And if they're dubious about what we tell them, it's probably because they're taking a bigger risk than we are, because after all, people doing service-based learning are eventually going to eventually and soon get on a plane and go home. Two thoughts that seem to be contradictory. actually are both true. That I'm sorry about the masculine pronouns. If you want to get something done quickly, in many cases, you better do it yourself. And the problem with doing it yourself is, of course, that after you leave, after you leave, then nobody cares about it. So if you really want to leave a lasting legacy, you better get a team together, and you better get that group engaged in what you're doing. Why am I bringing this all up? Because in many ways, education, at least what I'm familiar with, is often discouraged group efforts. That there is a concern in at least my universities to make sure that every student is really doing something on our own. Great concern about some students just watching other people's ideas. That may be true. I don't see that. I see everybody in a team trying to get their own ideas. Don't really worry about as it was much collaboration. Next slide, please. So this is just to be a review, and I don't think just anything that has to be pointed out here. So maybe just go on to the next slide. Easy. My mic is connected. Let me take off the earphone, which has the mic, and just see whether I can do it with the internal computer system. Can you hear me now? So let's go to the next slide. And I think we all know what service-based learning is. I'm sure most people in the audience know more about it than I do. But I think it points out the complexity of actual problems. And in the classroom and in the reading, we probably don't get to these real issues of complexity. And the second slide, it must be obvious that students will see the social and economic factors that are needed. Economic factors, I think, are self-evident. The project has to be self-supporting and profitable. The social factors is that people have very clear ideas about what they want. A rather trivial example, but one is illustrative, is in parts of the world, people don't like to have a yellow grain or red grain and all that. And if the aid project brings in a colored grain, local people will simply not eat it and would rather starve than break their social norms. I'm sure you can think of many other examples. And I think, and again, I think what student-based, what service-based projects do shows the importance of personal relationships. Often I had the experience of students come back and just simply can't believe that adults are so concerned about their own survival and respect and self-interest and all that. What I think service-based learning does is, at its best, it really forces students to think on their feet, which is what they're going to have to do in the rest of their lives. And you may say, well, how does this apply for people who are not engineers? And I think internships do the same thing. Next slide, please. And I don't think there's any point lingering on this slide. It was just to point out that other professions, medicine, law, use service-based learning and are pleased with it. Next slide, please. Sorry, yeah, okay, good. So we should think a little bit about what are the influential technologies of the future, and some of them are clearly more of the same, you know, Moore's law and all that, that devices are going to be able to do more things and all that. But I think two things we should at least be thinking about. One is artificial intelligence, and the other is technologies that support collaborations. And again, the students had better be prepared for what these new technologies are going to do. Next slide, please. So the term artificial intelligence is used in many different ways, but I think it basically comes down to either pattern recognition, analysis of big data and looking for patterns and wisdom there, or developing automated procedures based on the way humans learn. And analysis of big data can be done either by rather standard statistical methods, clustering, looking for the way the data fits together, or by the so-called neural networks. And what artificial intelligence does at its best is to suggest possibilities for designers. And many people ask, well, how does artificial intelligence fit into the education business? And I think it is useful in educational administration, predicting where the good students come from, predicting what fields are going to be of interest to students. And it probably is useful in ranking faculty members and recognizing who are good and who's excellent and all that. And it's certainly been proposed as a way of diagnosing learning difficulties with individual students. I'm a little dubious about the real effectiveness there, but probably because I don't know the programs at work. At one time, there was a lot of interest in so-called programmed learning. I haven't heard much about it lately, and Wikipedia didn't show any recent articles. But program learning, of course, was presenting students with some information, testing on the basis of that testing, deciding what new information the students should be given, and so forth. My impression is that students found these clumsy and lacking the nuances that a good student recognizes. Next slide, please. And I think many of us are familiar with the basic collaboration tools. Slack is often used. I think the advantage of Slack is that it allows many people, like Google Docs, it allows many people to work on the same document. It's a little easier to use an email and so forth. But I think the future software for collaboration do offer possibilities, and they often seem like artificial intelligence, model different projects. You can see how this would apply in a service-based learning system. You model and connect different related projects. The collaboration does the AI part is to recognize the similarities between projects, certainly suggests people who've been effective in other projects, and a more sophisticated thing is actually to look at the electronic interactions between users and use that to diagnose what's going on inside the organization, and finally keeping score with what is actually happening. Next slide, please. Sorry, next slide. I think this is fairly straightforward. The second bullet, I think, says it. Certainly the students I talk to now are much more concerned about social issues than their counterparts 50 years ago. Perhaps they're more knowledgeable, perhaps they're more afraid of what is going to happen. And I think you probably heard this remark before: if you're not a liberal at 20, you have no heart, but if you're a conservative at 40, you have no brain. And it'll be interesting to see whether the increased knowledge a student have now really has an effect on what kinds of social changes are made in the future. And it goes without saying that service-based learning points up political and social issues. Next slide, please. And some issues that people are concerned about is privacy and autonomy. And you can think about what the problem that these statements are addressing, that we think we're telling the computer some information that'll help us buy things in the future, and in fact, the data is being used to mishandle what we're doing, and the data is being used in terms of promotion and salary and so forth, and obviously automated decision making for job selection is a concern. Maybe we should do the next slide, please. And again, a problem that I think is going to be a concern with us is automation taking away jobs and developing a two-tier society. And I think we as faculty members have to worry about making sure that every student has an opportunity to learn technology and to be effective. And again, I think service-based learning here is going to help because people doing service-based learning will recognize the need for the user to be familiar with the equipment, technologically familiar. Next slide, please. And so the next two slides actually fit together. One reason appropriate technology fits in with service-based learning is the last slide here, that many service-based projects are based on appropriate technology. I guess everybody knows that appropriate technology is small-scale, usable control technology that is accessible to everybody. And I think the ethos of appropriate technology, which is frugality and suitability, is certainly important. The other ethos, of course, is to make a sensible decision of whether to rush to high technology or find something that is simpler and more effective. Next slide, please. Next slide was just to make a plea that academic institutions pay more attention to the mundane technologies, water, sanitation, housing, and so forth, which are often overlooked in a high-tech university. And actually, the war in the Ukraine has brought attention to crises in this area. Next slide, please. The other side of appropriate technology is building a business to make sure that the design actually gets out into the real world. People seem to think that if you build a better mousetrap, the world will beat a path to your door. Not true. Not true. That it's important to have an organization, a company usually, and the usefulness educationally is to show the students the importance of the entire system, product design, staff, supplier, and so forth. Next slide. And this is really the last slide, so cheer up. It's a plea that we as faculty members not ignore the people who are not engineers, that we should be teaching at least the rudiments of technology to all students, that we think it's important that they be literate in economics and political science, but they also ought to know something about the technology. And service-based, on the last two bullets, service-based learning certainly gets engineers close to the customers, to the users, but it also brings the users closer to the technology. Last slide. So I think there's a lot of exciting things going to happen in engineering education or in higher education in general. I appreciate you listening, and I'll certainly be very glad to discuss. Thank you again.
Hello.
So are we ready for Q&A?
Hi. Hi. Can you hear me, Professor Hazeltine? 佢好似聽唔到我，可能要對住個電腦，唔可以對住呢個機，對住邊個機？對住嗰個機。Hi, Professor Hazeltine, can you hear me?
I can just barely hear you. It might be easier if you just write down the question.
Okay. Okay. See whether there's any questions in the chat.
So could you write them down, Anson, on the chat board?
Right now. Okay. Any question from the floor? Stephen, please. should I write it down somewhere? Yeah, you better write it. Okay. My question is, Professor Hazeltine talk about the importance of AI and the collaborative technology and so on. That is, of course, very important, but it needs a lot of investment in terms of the hardware and software, the training of teachers and everything. As we all know, many teachers nowadays, even those in the developed countries who are struggling with teaching online with all those technology, let alone those who are in developing countries who have much less access to those technologies. If this is such an important issue, is it going to lead to more inequality in the field of education because of the importance of technology, which will make the so-called digital divide even worse? Thank you. I know that Grace is typing it, so you can send. You just send. Okay. So there is question, Professor Hazeltine. You can check the chat.
Well, I hope what's going to happen is what happened in many technologies, that the prices will go down. And I think we've seen that in almost everything that we deal with. On the one hand, as I say, they're costing less, and number two, they're much easier to use. So in principle, AI doesn't have to be that expensive. It requires a fairly complicated computer, and it requires sophisticated software, but when that computer and that software is spread over a large number of students, I don't think it really is going to be that expensive. To answer the last question, will the expense of these technologies lead to more inequality? I don't think so, because again, once these have been developed and implemented, they are going to be widely used, and so the cost, as I said, is going to be spread over a whole lot of users. I think the problem is much more trying to get basic technologies, computers and basic software out into the less affluent schools, and it must be a problem of training teachers, because the actual expense of the computers don't seem to be that high. I read again and again about computers being put in classrooms and not being used, and presumably they're not being used because the software is not available for the teachers.
Thank you. Thank you. Any other questions from the floor or online? No. If not, then please join me to thank Professor Hazeltine for his very insightful speech. Okay, thank you.